In this video, we are looking at kinetic and potential energy. I'm on page 42 of the student work text, and this image is one that I found on the internet. It is from test.com. I want to walk you through this example of how kinetic and potential energy trade places. Remember, the law of conservation of energy tells us that energy is neither created nor destroyed. So you're going to see in this example how energy changes forms, but it always balances. But before we start talking about this, let's review what kinetic and potential mean. Kinetic is the energy of motion, and potential energy is stored energy. And I've seen this little example quite often with this type of material because it really is a good illustration, a practical illustration of what is going on when you talk about kinetic and potential energy. So the first thing I want to do is take a look at the diagram and figure out what's happening. So we can just ignore the words for a minute. And I want you to look at the little man in the roller coaster car. And we're moving this direction, okay? So if you look at him up here on top of the hill, where he is just sitting still, and as he starts down the hill, you can imagine, you can almost feel what that would feel like in the roller coaster. He gets to the bottom of the hill and then swings upward again. So sort of let yourself feel what that is like to be that man in that roller coaster car. And now let's look at the math, if you will, that goes with this. Okay, when the car is sitting on top of this hill, they tell me that the kinetic energy is 0. Why would that be? Why would kinetic be 0? That is because he is not moving. He's just sitting at the top of that hill. Even if it's for a second or two, at that second in time, the kinetic energy is 0. So I'm going to show you how this could be written in a very sciencey looking form. So we could say at this point, the kinetic energy is 0%. So if the kinetic energy is 0, then the potential energy is 100%. Because he is sitting still, the entire energy potential is in the potential to move. He is not moving at all. He's sitting still, so the kinetic energy, the energy of motion, is 0. And the potential to move is 100%. So as he starts down the hill, things change. You have the energy that is motion at 50%, but he still has some potential energy in this space that he has to go. So it's about half and half. Half of it is coming from motion and half of it is still stored. But you notice, this is what I want you to notice, that the total energy, so energy total, is 100%. Notice over here where he is sitting still, the energy total is what? 0 plus 100, the energy total is 100%. So then we move over to this scenario where he is in full motion down to the bottom of the hill. So the kinetic energy, the motion of movement, is completely all. He is moving at this point. And so there is no potential energy left. All the energy is expended into the motion. And 100 plus 0 is 100. So total energy is still 100%. And then over here, that sweeping up movement, he's moving up to the top again. So the kinetic energy is pretty strong. There's a lot of movement happening there. 75%. And his potential energy is 25%. So there's a little bit of stored energy for him to start back down the hill. But this is a total of how much? 100%. So what I really want you to understand here, other than the difference between kinetic and potential, which we've covered up there, is the conservation of energy. Energy is neither created nor destroyed. It simply changes forms and cycles through the environment. So this particular example lets you see that, how when one increases, the other has to decrease for that balance to be maintained. And this example is also in the textbook. That's what really made me remember. If you look at page 94, it's another example of this same concept. It's almost identical. The proportions are the same and everything. So this is a very common diagram on exams, and that's why I wanted to share it with you. I don't know that you'll see it on a test, but if you do, you will hopefully have a little bit of background to help you. Okay, in the next video, we will continue talking about energy, specifically how it transfers from one thing to another, and then we will look at motion. So I'll see you soon.